You know that thing that rises in the sky every single day? Our sun. It feels like such a constant, a comforting presence in our lives. But here's the thing, our sun is not eternal. It's actually living on borrowed time. And in this explainer, we're going to look at its incredible, fiery, and very final countdown.
Okay, let's just dive right into the big question. When you look up at the sky, it feels like the sun has always been there and it's always going to be there, right? But the laws of physics, well, they don't mess around. For every single star, including our own, there is an end. So the answer is a big, definitive yes. It absolutely has an expiration date.
So, where are we in this whole cosmic story? Well, before we can talk about the end, we've got to understand what's happening right now. And right now, our star is basically in its prime. It's enjoying a very, very long and remarkably stable middle age.
To put a number on it, our sun is currently about 4.6 billion years old. I mean, that's a number so huge, it's almost impossible to really wrap your head around. But the key thing to remember is this: it puts our star almost exactly halfway through its entire lifespan. So in the grand scheme of things, it's a stable, middle-aged star just doing its thing.
And this brings us to a key scientific term you'll hear: main sequence. It's just the official name for a star that it's in its prime. It means the sun is in a stable, pretty predictable phase. And it's all powered by a simple but incredibly powerful process. Deep down in its core, it's just smashing hydrogen atoms together. That fusion releases the tremendous energy that we feel as heat and see as sunlight.
But, and you knew there was a but coming, that stable hydrogen-burning phase can't last forever. The fuel tank is not infinite, and that means a final countdown has, in a way, already begun. So here it is, the headline number. Based on its size and how fast it's burning fuel, scientists figure the sun has about 5 billion years of gas left in the tank. 5 billion years until its main sequence life comes to a close. And then, everything changes.
So what's the trigger for this massive change? It all comes down to that fuel in its core. Right now, it's running on a vibrant, steady diet of hydrogen. But in 5 billion years, that main fuel source is going to run out. And that single event is the catalyst that kicks off the sun's dramatic final act.
And let me tell you, that final act is a spectacular one. When the hydrogen runs out, the sun won't just, fizzle out. Oh no, it's going to begin a radical and violent transformation into something called a red giant.
This whole process happens in a pretty clear sequence. First, the hydrogen fuel is gone. Without the energy pushing outwards from fusion, gravity wins. The core collapses on itself, becoming incredibly hot and dense. All that extra heat then ignites the leftover hydrogen in the sun's outer layers, causing them to balloon outwards on an unbelievable scale.
And the sheer scale of that expansion is just staggering. Our sun is going to swell up, becoming hundreds of times bigger than it is now. It'll grow so enormous that its fiery edge will just engulf the orbits of the inner planets. It'll completely swallow Mercury and Venus, and it might even reach Earth. But this violent, enormous red giant phase, that's not the final chapter. After all that fury, things get quiet. The sun's long life ends not with a bang, but with a slow, fading whisper, as something called a white dwarf.
So after that red giant phase hits its peak, the sun's gravity just won't be strong enough to hold on to its big, bloated outer layers anymore. It'll just gently puff them away into space, creating this beautiful, glowing shell of gas. Funnily enough, we call this a planetary nebula. It's like a stunning final breath from a dying star.
And what's left behind? The star's tiny, dead core, a white dwarf. This thing is incredibly dense. We're talking a single teaspoon of it would weigh several tons. But it's not generating any new energy. It's just a cooling ember, really, the ghost of the star it used to be.
And this cosmic ember isn't going to go out quickly. It will just hang there in space, radiating away all its leftover heat for billions and billions of years. It'll just keep slowly dimming until it becomes a cold, dark object, a black dwarf, the true final end of its light.
So, wow. After that journey, billions of years into the future, let's bring it back home. A dying star, a red giant, a fading dwarf. What in the world does all this cosmic drama mean for us right here, right now?
And honestly, this is the most important takeaway for all of us. While the sun's end is definitely going to happen, it is not happening anytime soon. The fact is, we have plenty of time, billions of years.
It's a cosmic event on a scale so grand that for now, it's a matter of scientific fascination, not immediate concern.
Which, leaves us with this final, really profound question. The sun has given us a very, very long timeline. It's a gift of time that's almost unimaginable. So the real question isn't about the sun's future anymore. It's about ours. What can a species like us achieve? What can we become with billions of years of sunlight left to work with?